Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from January 2024 paper theory. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Most of the time, many students, they feel P3 exam is very difficult. But P3 exam is the easiest exam if you have good understanding of basics of physics. If you're struggling with P3 exams or you have kind of fear about P3 exam, then watch this video carefully, and also I have uploaded an other video from 2023, one or two videos, and also I have uploaded exam tips for P3. If you watch all of them, and then you will feel there is no more fear about P3 exam. So watch them carefully, and if you have any questions, you can also leave your questions in comments and I will try to answer as soon as possible. So watch this video carefully and try to improve your practical skills. Mean how to record data, how to take measurements and other precautions. So you just need to understand few points, means not too many concepts about P3. If those basic concepts are clear to you, then P3 exam is quite straightforward one. And P3 exam is very important exam to understand physics, because physics starts with experiment, mean it starts with measurements. So understanding of this paper is very important to understand physics in a right way. Question 1 says a student had a stack of 50 sheets of paper. He measured the dimensions shown, means x, y and z. The student used a balance to determine the mass of the stack of paper. The reading is shown below. State the resolution of the balance. Resolution is the smallest measurement we can take with the help of that instrument. So smallest measurement. Now if you look at this one, here we have this decimal place. This is the decimal place. So how many decimal places we have here? We have 3 decimal places. It means that the smallest reading we can take with the help of this one. So this is when nothing is placed on this, so we will see this one. So what is the smallest reading we can take with the help of this one? The smallest can be 1, means 0.001 kgs. So this one is the resolution of this balance. So resolution simply is the smallest measurement you can take accurately with the instrument. Smallest measurement you can take accurately. So very important one, accurately. The smallest measurement. So in this case we can take the smallest measurement, that is 0.001. So let's say now we have another balance. The reading on that balance is 0.01 for example. So what is the resolution of this one? The resolution of this one, you will simply say this is 0.01. And if we have another one that has a resolution, that is, let's say the reading on the balance is given to us, that reading is, let's say that is 2.50. So what is the resolution of this one? So you will say this is 0.00. It means the resolution will be 0.01. So these two balance, they have the same resolution. And if we have another balance, reading on that is 2.4. So what is the resolution of this one? So we can simply write down first of all 0.0, and the last 0 you can write down, this is 0.1 if the unit is kgs. So this is 0.1 kgs. This will be equal to 0.01 kgs. This is also equal to 0.01 kgs. So this is how you can determine the resolution. So the resolution of this one simply we can say is 0.001 kgs. This is. So you have to read the unit from the balance. Second part says determine the percentage uncertainty in the mass of the stack of paper. So how we can determine percentage uncertainty? So simply we can say this is percentage uncertainty. Percentage uncertainty for single reading, single measurement, this is equal to half resolution of the instrument, half resolution divided by measurement itself, means the reading we have taken with the help of instrument. So this is the formula, and you have to multiply this one by 100. So in this case, our resolution was equal to 0.001. So we have to divide this one by 2, and we have to divide by the reading of the measurement. Reading was 2.070 kgs. So this is in kgs, and we need to multiply this one by 100. So by 100. So if we solve this, we will get 0.024%. So this is how we can calculate percentage uncertainty, and this is only for one reading. If we have taken one reading, if we have taken multiple readings, so let me write down here for multiple readings, or you can say for multiple measurements. How to calculate absolute uncertainty? First of all, simply we can say how to calculate absolute uncertainty. So this is first thing you need to understand, how to calculate absolute uncertainty. We use half range method, means you will take the maximum reading minus you will take the minimum reading, means simply the range divided by 2. So this is the half range. But if some data is anomalous data, anomalies there, outlier, means one or two readings are totally different from others, you can simply ignore them, and then you can find the range of remaining measurements. So this is also very important point. And so we can find absolute uncertainty. If we have absolute uncertainty, then we can find the percentage uncertainty. So here we will have absolute uncertainty. So this is absolute uncertainty. So these are important points you need to understand step by step. So absolute uncertainty, we will be dividing by the mean value. Very important one. You have to calculate the mean of the readings, and then you need to multiply this by 100. So then you will be able to find the percentage uncertainty. Part B says the student used vernier calipers to measure the thickness Y of the stack of paper. Explain one technique he should use to determine an accurate value for Y. One technique. So first thing we need to understand, in this case we are using vernier calipers. So we can talk about vernier caliper. So we can talk about instrument. As we are using vernier caliper, we have to check vernier caliper for zero error. If it has zero error, we need to adjust the final reading. For example, if the zero error is positive, means the reading measured by the vernier caliper is higher than actual reading. And if the zero error is negative, so how about the final reading? So we can write on here the final reading we should subtract. So let's say we have, this is the measured value, and we have to subtract zero error in this case. So this is our reading, so we can say this is our reading from the instrument, and here we have zero error, so we have to subtract that. If zero error is negative, then the final reading we have to add zero error. Final reading means the actual reading. This will be equal to the reading from the instrument plus zero error. So we have zero error here. So this is zero error. So we can say this is zero error. We have to add or we need to subtract. It depends on type of zero error. So this is one thing we can do about instrument. So we can make sure what we measure from the instrument, that is right. And the second thing what we can do is, as we have the thickness, for example, in this case, so we have the thickness, this stack of papers, we can measure thickness at different positions, and then we can take average. The diameter of something, you can also talk about measure diameter at different positions and calculate average. In this way, we can minimize random error. By measuring and taking average, we can minimize random error. And with the help of this technique, we can minimize systematic error by checking zero as systematic. So we can reduce systematic error if we check for zero error. So these points we can mention. Thickness whenever you need to find out. For example, I have these papers here. So you can see here I have these papers, and if I need to find the thickness of one paper, for example, if I need to find the thickness of one paper, I will take many papers, I will make a stack of them, and I will find the total thickness, and I will find thickness at different positions, and I will calculate the average total thickness, and then I will divide by number of papers, number of these sheets, so I can find accurate value of one sheet of paper. So these are the points you need to understand. We can simply say check for zero error, and with the help of this one we can eliminate systematic error. In the answer you should write down what kind of error it will minimize: systematic error. We can also say measure thickness at several positions and calculate average value. It will reduce effects of random error, mean it will reduce random error. So these are important points. Next time they can give you something little different. Maybe they can ask you to find the diameter of ring, diameter of any solid object. So the same point you can mention in that question as well. And if they ask you to use micrometer, for example, you can also talk about the same points. Part C says the student used the measurements from the stack of paper to determine the density of the paper. For part C1, determine the density of the paper in grams per cubic centimeters. So how we can calculate density? So this is the first thing you need to understand. Density is equal to mass over volume, means the mass of stack of paper divided by volume of stack of paper. So here we have volume, and the mass in the last part was given to us, mass was given, that was equal to 2.070 kgs. So we can convert this one into grams. So we have 2.070 multiplied by 10 to 3, so the answer will be in grams. We will get 2070 grams. So now we can write down the value of the mass, that is equal to 2070 grams. So this is in grams, and these values are given to us in millimeters, so we can convert them into centimeters. So simply we need to divide by 10. So here we will get 21.0 centimeters, and here we will get 4.27 centimeters, and here we will get 29.7 centimeters. Now we can plug in these values here. We have 21.0 and we have 4.27, all of them they are in centimeters, and we have 29.7 centimeters. If we solve this one, we will get 0.777 grams per cubic centimeters. Grams per cubic centimeter. So for this one we need to understand, as our given data, this has 3 SF. So you can see it has 3 SF, this has 3 SF, this has 3 SF, and this also has 3 SF. So the final answer also should have 3 SF. In the final answer we consider the least number of SF in the given data or one more. So the final answer is 0.77 grams per cubic centimeter. Second part says explain why making measurements on the whole stack of paper is better than making measurements on a single sheet of paper. We have already discussed about this one. So if you need to find the thickness of one sheet of paper, it's better to have many sheets together placed on top of each other, and then you can determine the thickness of one sheet of paper. So that method is a better one instead of just using one sheet of paper. Now let's try to understand why, if we have a stack of sheets of paper, why that is better to measure thickness of one sheet of paper. So let's try to understand that with the help of percentage uncertainty. So we need to understand percentage uncertainty. This will be equal to half resolution of instrument. So we have discussed this point at the beginning, and now we will discuss again this point to answer this question. Half resolution divided by the measurement. So here we have divided by measurement, and we have to multiply this by 100. For one instrument, resolution is the same. for the same instrument, you need to understand, for same instrument resolution is the same. But if we can increase this measurement, if we increase this one, it means the percentage uncertainty, this one will go down. So that's the reason we place many sheets of paper on top of each other to find the thickness of one sheet of paper. So in this case, we can minimize percentage uncertainty. I hope this makes sense. Now let me show you the answer, how you can write down your answer. This question has 2 marks, so you can mention 2 points in your answer. So these 2 points, if you write down in your answer, you will get 2 marks. First, you can say the measurements will be larger if we have stack of papers, and it will reduce the percentage uncertainty. So if you write on these 2 points, you will get 2 marks. So this is how we need to answer. I hope this one makes sense. So this is very important point, very important point. So you need to understand why we measure time period for many oscillations. The same is true for pendulum. Let me explain you a little bit about this one. Next time they can ask you a question about this. For example, you have a pendulum. You need to find out its time period. I mean time taken from this point to come to this, so this way, and to come back to this point again. So this is one time period. So when we need to measure the time period of simple pendulum, we always measure time for more than one oscillation, means at least 5 or 10 oscillations, and then we find the time period. So why we do like this? The reason is that if we have higher value of the measurement, we can minimize the percentage uncertainty. So the same reason is true for simple pendulum. Question 2 says, a student investigated the efficiency of an electric motor using the apparatus shown in the figure. The motor was connected in a circuit including a battery and a switch. The student connected additional components to determine the power of the battery. Power of the battery, we can simply say P is equal to VI. Complete the circuit diagram for the circuit the student should use. So we need to determine the power of the battery. So we need to find the potential difference. So we need to use voltmeter. So voltmeter. We need to find value of current passing through the motor. So it means we have to use ammeter. So these 2 additional instrument we need. And if you look at this one, we have the positive terminal of the battery. Then after this one, we have this motor. Motor is connected here. And after motor, we have the switch. And then this is connected with negative terminal of the battery. So simply, first of all, we can draw this is positive terminal of the battery and this is negative. And here we can draw the switch, positive terminal. So we can draw the switch here. So this is representing the switch. So we can draw, this is the switch. And we can connect this one with motor. We need to find current passing through the motor. So we need to connect ammeter in series. So we can connect ammeter in series. And we also need to find PD across the motor. So we have to connect voltmeter across this motor. So this is how we can draw the circuit. So this one is over switch. So this is switch. As question said, complete the circuit diagram. So we can also label actually these components in the circuit. You can also label. So this is battery. You can write down this is ammeter. This one is motor and this one is voltmeter. So it's better you can also label this diagram. Part B says the student closed the switch in the circuit and the motor lifted the mass from the floor. She used a meter rule to measure the height gained by the 1 kg mass in 10 seconds. Describe how she should measure a single value of the height gain as accurately as possible. You should include the use of any additional apparatus needed. Now, before we answer this question, you need to just imagine you are doing a real experiment. How you can find the height gain? So you have to first of all think about this one. So this is the best way to answer. tricky questions. Now let me explain you how we can find the height of this mass. In order to find height, we have to use meter rule. Now we cannot hold meter rule with this like this, so it's better we clamp the meter rule. So simply, first of all, we can say we can clamp the meter rule next to this mass. So this is our meter rule. We need to clamp this one, so we will be using retort stand. So this one is our retort stand, so we have to use the retort stand. So this is the rod of the retort stand, and here we have the clamp, so we can use clamp here to hold this meter rule. And also we need to make sure this meter rule is vertical. So how we can make sure? We can place set square. So we can place set square and we can check whether this one is vertical or not. We can also attach a marker at the bottom of the mass, so we can reading from the scale easily. So these are the points we need to understand. And also we need to understand, when we read the scale, we need to read scale at eye level. So these are the practical points you can include in your answer. Now let me show you the answer, how you can write down the answer. In your answer you can mention these 4 points because this question has 4 marks. You can say clamp the meter rule next to the rising mass using retort stand. We have mentioned that point. Use set square to make sure the meter rule is vertical, so we have already shown here. And attach a marker at the bottom of the mass. So here we can attach marker, something you can attach here. So this is the marker. Take measurements perpendicular to the scale using a set square, so we can avoid parallax error. So these 4 points you need to write down. So whenever you need to measure the height, you can talk about these points. Second part says explain why repeat measurements are appropriate for this measurement. In this case we are measuring height. So first of all we can say we are measuring height, so there can be parallax error. So when we are measuring, there can be parallax error. And we also need to measure time, in this case time for 10 seconds. So when we are measuring time, due to reaction time there can be errors. So due to reaction time. Now if we repeat these measurements, so the value of parallax error will be different. It can be higher slightly, it can be lower than the actual value due to parallax error, and reaction time also can be little bit higher, little bit lower every time when we repeat. So we can simply say these two, they will cause random error because the readings will be sometimes higher, sometimes lower, so it means that is random error. Now the question is how we can minimize this random error. Random error, to minimize, as we mentioned before, we can repeat and we can calculate average. By calculating average value, we can minimize random error, but systematic error cannot be minimized. So in this case, we are taking more than one reading. So there is random error due to parallax error and also due to reaction time. If we take only one value, for example, so in that case, due to reaction time, our value will be higher than the actual value. So that you can say systematic error. But in this case we are repeating, so that becomes random error because readings will be sometimes higher, sometimes lower, so it means that is random error. And random error can be minimized by taking average. So this is how you can answer this question. Now let me show you the answer, how you can write down your answer. In the answer you can mention these points. You can say there will be a random error due to reaction time and parallax error, and random error will cause variations in the measure value, means sometimes value higher, sometimes lower. So by repeating we can minimize random error, and by calculating average we can get more accurate value. And this point is very important, so let me clean this one. So this is something you need to keep in your mind. Random error can be reduced. Random error, it can be reduced by taking average, but not systematic error. If you take average, we cannot reduce systematic error. Part C says explain how the measurements made by the student should be used to determine the efficiency of the motor as it lifts the mass. So pretty straightforward question is asking you to determine the efficiency. Efficiency, simply we can say efficiency is equal to useful power out. So we can say useful output power. So the main idea you need to understand, useful output power divided by total input power. But when we say input power, it means we are talking about total input power. So simply we can say input power, or you can say power input. So what is the input power? So input power simply is P is equal to VI. So this is the input power, means the power of motor. So this is the input power, P is equal to VI. And what is the useful output power? That is the gain in potential energy of this mass per time. So we can say the power out, that is the change in GPE of this mass over time taken over T. So simply we can say that will be equal to mg delta H over T. So we can write on here, so this is mg delta H over, so we can write down mgh over T, so over T. So this is P out, this is P in. So if you write on this one, you will get 3 marks. 3 marks for this question. So these are very easy to get these marks. Simply if you understand what is efficiency, that is equal to P out over P in. Useful P out over P in. And P out, useful P out we have. This is, and this is power in, mean input power. And we can find the efficiency. I hope this paper makes sense to you, and I also hope you have better understanding of these questions. And these videos are helping you to improve your understanding of physics. Please like and subscribe, and if you are looking for extra resources and one-to-one guidance, so you can also join Patreon. See you next video. And the remaining 2 questions from this paper, I'll be uploading before your exam. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from January 2024 paper theory. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. As I mentioned before, P3 exam is not difficult. You just need basic understanding of measurements. If you have basic understanding of physics, then no more fear of P theory. So watch this video carefully and try to improve your understanding. When you have good understanding, P theory exam is just a piece of cake. And also, if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. Let's study together, let's improve together. First of all, let me explain you what is meaning of this one. Take measurements perpendicular to the scale using a set square. So you can see in this case, this is our meter rule. So this is meter rule, and this one is our set square. So this is set square, and you can see this angle between them. This angle is 90 degrees. So first of all, you have to place your set square like this, and then this part you have to align with the bottom of the mass. So you have to align this one with bottom of the mass. So this one is the mass, this mass we have drawn here. So then you can read from the meter rule. So this is how you can use set square, and this is meaning of take measurements perpendicular to the scale using a set square. I hope this helps. If you have still any questions, you can ask me in comments. Third question says, a student used a laser and screen to determine the diameter of a hair. The apparatus was arranged as shown in the figure. For part A, identify a health and safety issue caused by using a laser and how this issue may be dealt with. So first of all, we need to understand, if you look at laser directly, light of laser is very intense. So it can damage our eyes. So we should not look at laser directly with naked eyes, or we can wear dark glasses to protect our eyes. So these 2 points you can write down in your answer. Now let me show you the answer, how you can write down your answer. In the answer you can mention these 2 points. You can say laser light may cause damage to the eyes, so don't look directly into the laser beam, or you can wear dark safety glasses. Part B says the student placed the screen 2 meters from the hair. He switched on the laser. A diffraction pattern was produced on the screen as shown in the figure. The student used a meter rule to determine the distance between adjacent minima. Describe how the student should determine an accurate value for the distance between adjacent minima. We can answer this question using different ways. One possible way is we can draw the line here. So this is the center of minima, and next minima we have here, so we can draw another line here. So this is the center of next adjacent minima, and the value of distance x between them we can find. Let's say this one is x, and we can repeat this one for many adjacent minima, and finally we can calculate the average value. So this is one way to do. And the second way is we can find the value of x for 10 adjacent minima, and we can divide by 10. So we can also find value of x, and that value will be more accurate. So you can write any one of them. I'll be writing the first one in this case. So how we can write down the answer? This is how you can write your answer. You can say measure the distance between center of adjacent minima, repeat for different pairs of adjacent minima, and calculate a mean value of measurements. So this is how we can do. And we follow the same way. For example, when we measure time period of simple pendulum, we measure time for at least 5 oscillations or 10 oscillations, and then we divide that time taken by number of oscillations. So let's say this is the time taken for 10 oscillations. We will divide by 10, and we can find the time period of simple pendulum, because this will improve the accuracy and this will minimize the percentage uncertainty. And the same you can also do for this type of questions. Second part says explain how the student could modify the arrangement of the apparatus to reduce the percentage uncertainty in this value. So first of all, we need to understand how do we calculate percentage uncertainty. Percentage uncertainty, this can be equal to half resolution. So we can say half resolution divided by measurement multiplied by 100. If we're using one instrument, so for the same instrument, half resolution, this one will stay constant if you're using the same instrument. So this value is constant for any instrument. Means each instrument has its own half resolution. And this measurement we can change. So we can change this one, but we cannot change half resolution for any instrument. That is fixed value for one kind of instrument. So we can increase the measurement. So if we increase the measurement, it means that percentage uncertainty, this one will go down. So now the question is that how we can increase measurement in this case. So we have already discussed. Imagine that this is representing one dark fringe. Simply we can say this is representing one minima, and this is representing an other minima. So this is another minima, and the distance between these two, we can also mark this distance. Let's say this distance between them, the separation between them, this is equal to x. So if we increase x, so it means that we can minimize percentage uncertainty. So how we can minimize percentage uncertainty? We have to increase x, and in order to increase x, we have to increase the separation between this, means separation between the slit and the screen. So if we increase this distance, let's say this distance is capital D. So if we increase this distance between slit and the screen, value of x will increase. So may we see these minima like this, so the distance will be increased. So this distance will increase. So in this case, we can reduce percentage uncertainty by increasing the distance between slit and screen. So these 2 points you can write down in the answer. This question has 2 marks, so we can write down these 2 points. The first point, you can say increase the distance between the hair and the screen, as this will increase the separation between minima. Means when we increase this, it will increase value of x. Part C says the student repeated the procedure using 3 different lasers. Each laser produced a different wavelength of light. The student calculated the diameter d of the hair using each laser. He recorded the values as shown in the figure, as shown in this table. Determine mean value of d. Very straightforward question, very easy question. So simply we need to calculate the mean value. So simply you can say we need to calculate the mean value of diameter, and different values of diameter are given to us, and the unit of this one is micrometer. So simply we can write on here 76.0 micrometer, we have 84.4 micrometer, plus we have 77.1 micrometers, divided by the number of readings. We have 3 readings. Now if we simplify this one, we will get 79.2 micrometers. So this is our final answer. One thing you have to be careful is, as this data, this one has 3SF, this has 3SF, this has 3SF, means the given data, it has 3SF. So the final answer also should have 3SF. So answer should have, so let me write down number of SF. Let's say we have raw data, so let me write on here. If we have raw data, let's say this has 2SF, then this has 3SF. So how many SF we need to use in the answer? In the answer, you can use 2SF, least number of SF, 2SF. So it's better to use 2SF, or you can use one more than the least. So the least is 2, so you can use also 3SF. Least number of SF in the data means the number of SF in the answer should be equal to least number of SF in raw data, or one more. Now let's say we have data that has 2 SF and that has 4 SF. So how many SF we have to use in the final answer? So the least number of SF we have 2. So your final answer can have 2 SF or one more. So it can also have 3 SF. So this is the rule you need to understand. Second part says determine the percentage uncertainty in the mean value of the percentage uncertainty. So in this case, you can see we have multiple readings. So it means we have to use half range method. So first of all, we will try to find out absolute uncertainty. So absolute uncertainty in data, absolute uncertainty. So we can write down absolute uncertainty, and this is equal to the half range of given data. So we can say this is equal to half range. So in this case, this one is the maximum reading, and we can say this is max, and this one is minimum reading. So we can write on maximum minus minimum. So this is the range, but we need to calculate half range, so we need to divide by 2. So we will get in this case 4.2 micrometers. And in order to calculate percentage uncertainty in D, we have to use the half range, means the absolute value. So we have to use the half range divided by the mean value. So we have to use the mean value of D multiplied by 100. So half range we have that is equal to 4.2, and the mean value is 79.2 multiplied by 100. So in this case we will get 5.3%. So this is how you need to calculate. So simply we can say percentage uncertainty in mean value of D is 5.3%. But one thing we need to understand, let's say we have more readings. Let's say we have laser 4 less than 4. And this answer, let's say this is 105.4. So you can see this data is very close to each other, but this value is totally different. So this is anomaly, this is due to error in measurements, or you can say this is outlier. So you need to ignore this one when you calculate half range. If one value is totally different, one or two values are totally different than rest of the data, so you can ignore that one when you calculate half range. So this point is very important. Next time they can give you data and they can ask you to calculate half range, so you have to ignore this value. So this is very important point. Part D says, in a different experiment, the student applied force to stretch the hair. He determined the breaking average stress for hair as 181 megapascals with a percentage uncertainty of 6%. The student suggested that the breaking stress for hair is the same as the breaking stress for copper wire. Deduce whether the suggestion is correct. Breaking stress for copper wire is 210 megapascals. So in order to answer this question, first of all, simply we can say for hair, breaking stress is equal to 181 plus minus 6%. It means that the actual value of breaking stress, it is between 181 minus 6%, you can say. It also means that 181 multiplied by 0.94 means this value, and the upper limit is 181 plus 6%. It means that 181 multiplied by 1.06. So this is the lower limit and this one is the upper limit. So simply we can calculate this upper limit. If this limit is higher than 210, it means suggestion can be correct. If the upper limit is lower than 210, it means suggestion is not correct. So if you multiply these two, you will get 192 megapascals. As this value is low, so let me write down here as 192 megapascal. This is lower than 210 megapascals. It means not correct. So suggestion is not correct. So simply you can say, so suggestion is not correct. So this is how you can answer. So in the answer you can write down 192 megapascal means the upper limit, you can say here as the upper limit. Upper limit 192 is less than 210 megapascal, so suggestion is not correct. So this is how you can answer. In the answer, for example, you can write down, let me little explain you how you can write down the answer. You can say as upper limit for breaking stress of hair is equal to 192 megapascals, and 192 megapascals is lower than 210 megapascals, so suggestion is not correct. So suggestion is not correct. So this is how you can answer your question, and this question is a typical question, mean this concept is typical. You will see in other papers as well. So you need to understand how to deduce whether the suggestion is correct or not. So in this case it is not correct because this value is not in this range, so it means this is incorrect. Some student, they asked me before, why do I multiply with 1.06? It simply means that 100, let me explain a little about this one. 181 100% plus, it means 181, it is 6%. So you have to multiply this one with 0.06 and that one will be equal to 192. So this is 6% extra than this value. So you have this value, you have to add 6%, and 6% means that 6 divided by 100. So it means this is equal to 0.06. 0.06. So this is how you can answer. So this is 0.06. You can also understand from here, for example, we have 181, we have plus 181 multiplied by 0.06. So you can simply take 181 common, so you will have here 1 plus 0.06. It means that you have 181, you have to multiply by 1.06. I hope it will help some of you and it will answer your question, why do we multiply with 1.06? So you can understand this way, you can understand like this. If these videos are helping you, they are helping you to improve your understanding of physics, please like and subscribe, because your encouragement is very important. These videos, they take time and they need energy. So if they are helping you, support your teacher by liking and subscribing, and also share this one with your friends and classmates. So that is kind of support from your side. I hope you will do this. Question 4 says, a student investigated the inverse square law for light using the apparatus shown in the figure. The student used a meter rule to measure the distance d between the filament of the bulb and the sensor on the light meter. The reading on the light meter is the intensity I of the light. Explain how two sources of error can be reduced in this investigation. So first of all, we need to understand this experiment is about light. So any experiment where light is involved means light experiments should be done in a dark room. So this is one thing you can say, experiment should be done in a dark room, because external light, it will affect the results. So this is one thing you can say. The second thing we can say is, in this case, d is this distance, d is this distance, but this is not right. We need to measure distance from the center of this bulb, center of filament. So we have to measure distance from the center of the filament. And with the help of meter rule, we cannot measure distance from the center of the filament. That distance will not be accurate. So how we can measure distance accurately, we can find out. So let me little clean this one. So we can find, first of all, the diameter. We can find out diameter of this light bulb, and after finding the diameter, we can add that radius. So we can say here, we can take this point and we can take this point, so we can find the diameter. And after finding diameter, we can find the value of the radius. So this one is diameter. We need distance from the center of this filament. So the d new, actually the new value of d, it should be d plus the radius of the bulb. So this is how we can minimize the error. So these are 2 points you need to mention in your answer, and this question has 4 marks if you have mentioned 2 points, and also you have mentioned how to fix them, means 2 sources of error, and how to minimize them. You will get 4 marks. Now let me show you the answer, how you can write the answer. In the answer you can mention, it cannot be measured to the center of the filament bulb accurately using meter rule. So measure the diameter of the bulb separately and add the radius to the measurement of d. So that will be our new value of d. The second point is a very common one you can write on for any light experiment. We can say the background light will affect the readings on the light meter. So do the experiment in a dark room. Part B says the relationship between I and D is given by this equation, where k is a constant. Explain why a graph of I against 1 over d square should be a straight line through the origin. Pretty straightforward question. So simply what we need to do is we need to write down I is equal to k times 1 over d squared. So you can little bit rearrange this one. Now we need to compare this one with straight line equation. We can say y is equal to mx plus c. So we can write on 0 here as well. And so in this case, we have on y-axis, this is current. On x-axis, we will have this one. And the gradient in this case will be equal to k. So simply we can say, in this case, gradient is equal to k, and k is a constant. So it is given to us, k is a constant. So k is a constant. So it means it has to be a straight line with constant gradient. And it has to pass through the origin because y-intercept is equal to 0. So we can say as y-intercept is equal to 0, so it has to pass through origin. So simply you can say pass through origin because y-intercept is equal to 0 and gradient is equal to constant, so it has to be a straight line. So we can say it has to be a straight line with constant gradient. Straight line with constant gradient, or we can say with only one value of gradient, with constant gradient. So this is how you can answer the question. So very common question also. Any equation is given to you, most of the time you simply need to compare with this straight line equation. Second part says the student varied d and recorded corresponding values of I. She recorded the results in the table as shown. Complete the table with corresponding values of 1 over d square. Use the additional column to record your process data, means calculated data. So we have to record here 1 over d square. So first of all we can write down the quantity, and also we need to write down the unit of the quantity. So here we have d, and this d has 3 SF. 3 significant figures. So we also need to use here 3 significant figures. You can see all this data has 3 SF. This also has 3 SF because it has non-zero digit on the left side, and also it has decimal and non-zero digit on the left side of the 0. It means those zeros are significant. So it has 3 SF. So in this column, all values should have 3 SF. So how we can calculate 1 over d square? So simply you can say 1 over d square, and value of d is 0.125 square. If you solve this one, we will get 64.03 SF. And so simply you can write on here 64.0, and you can do these steps for rest of the values. Now let me show you the final table. This is how your table should look like. So these are the final values. If you have done this one, you have completed this column and also this heading, you will get 2 marks. And for the third part, we need to plot a graph of I on the y-axis against 1 over d on the x-axis on the grid opposite, and this has 5 marks. So the graph is very important. You have to do graph carefully. And for next part, we need to determine the value of k from the graph, and this one has 3 marks. So you can see this one has 10 marks, means you need to complete the table, you need to draw the graph, and you need to calculate gradient. If you do this, this has 10 marks. So you have to be very careful with this part of the paper, means this question, because this question can improve your grades and can give you higher score in this paper. So try to master this type of question, mean questions about graph. So we will go to the next page and we will sketch the graph, and then we will find the gradient. Now let's try to sketch the graph. In the question, it is given to us that this quantity should be on the y-axis. In the question, it is given to us, and this quantity should be on x-axis. So we need to write down the quantity here. So we can say this is I, and the unit of this one is watt per square meter. And on x-axis we have quantity that is 1 over d square, and the unit of this one is per meter square. So this is first thing you need to do. On y-axis and on x-axis you need to write down the quantity, and also you need to write down the unit. The next step is we need to choose the scale along x-axis, and also we need to choose scale along y-axis. For x-axis, you can see the maximum value. So how we can choose the scale? Maximum value is 64 minus we have minimum 1.78, and we can divide this one by number of big square. How many big square we have? 1 2 3 4 5 6 7 8, and this difference, so we can divide by 8. So approximately, for example, this one, if I say 70 divided by 8, around I can write down is 10. So around, you have to choose the convenient number. So in this case, 10 is convenient one, so we will be using here. Actually, if we divide this one over, it will be smaller than 10, but we have to choose convenient number so you can sketch graph easily. Now for the y-axis, we can also do the same one. For the y-axis, maximum value, so we can write on the scale. We have maximum value, that is 996, minimum value is 18, and we need to divide by number of big squares. So here we have 1 2 3 4 5 6 7 8 9 10 11 12. So we can divide this one by 12. So this is about 1000 roughly, I'm talking about roughly, and this is 12. We can take this one as 10, so we can choose around 100. So this is nice number. So with the help of this one, easily we can sketch the graph. So now we have, this is approximate this value, so you will get the exact value. Then you need to think about a number which is easy to plot the graph based on the given data. So these two numbers we can use to sketch the graph. Now if we have these scales, now let me show you how you can sketch the graph. So this is how you can sketch the graph. So we have on y-axis, we have 100, 200, 300, 400, 500, and so on. And here we have 0, 10, 20, 30, 40, 50, 60, 70. Actually, real graph has 8 boxes. So here you can also write down 80 here. You can write down here 1100 and 1200 on the real graph. This is just sample graph to make it easier for you. So this is just sample, but you have to follow these steps. Now this is our graph. You can see in this case, this point is above this line, so this is best fit line. This point is above this line, and this point is little below, and this point is also little below. And if we look at the vertical distance from the line, distance is almost same, so it means this line fit all these points. And this line means your data, when you plot data, means this point and this point, it should cover more than half of the graph paper. So this is very important. Now you can see along y-axis it cover more than half of the graph paper. Along x-axis it also cover more than half of the graph paper. It means this graph is acceptable. Next thing what we need to do is we need to calculate the gradient. In order to calculate the gradient, we can simply draw this triangle. You can take any 2 points on this best fit line, and the distance between points has to be more than half of the length of best fit line. So these 2 points we can take. Now we need to calculate the gradient. So we can calculate simply gradient now. So we can take this point. So this value is about 940, and this y value is 200 divided by x value. X value at this point we can read this is 60. So here we have 60, and x value from here, this is about 13. So this is 13. So if we simplify this, we will get 15.7. 15.7. Now what is the unit of this one? Unit. So on y-axis we have unit, that is watt per square meter. On x-axis we have unit per square meter. So it means per square meter will be cancelled. We will get 15.7 watts. So this is how you can sketch the graph. I use this sample graph actually, but you can do graph by yourself. You can follow these steps. These are the points you need to understand how to sketch a proper graph. And if you have any questions about graph, you can leave your questions in comments. I will try to answer as soon as possible. And this method every time you can use when you need to find the unit for the gradient, and always write down a unit for the gradient. Part 5 says the student switched off the filament bulb. She recorded the intensity of the background light as 4 watts per square meter. Switched off the filament bulb means when filament bulb is not there, what is the intensity of background light? That is 4 watts per square meter. The student then switched on the filament bulb. She moved the light meter to change D until the reading on the light meter was 8 watts per square meter. Determine the distance between the light meter and the filament bulb. So in this case we have background light intensity, so we can say we have background light intensity. So we can say light intensity, that is 4 watts per square meter. So now we can write down intensity of light bulb. Intensity of light bulb. So intensity of light bulb, that has to be equal to 8 minus 4. So we can say that is also equal to 4 watts per square meter. Now we need to calculate value of D, but in the question it is given to us that intensity is equal to K times 1 over D square. Then K is the gradient. K is equal to gradient, and value of gradient we have already found in the last part, that was equal to 15.7 watts. Now simply we need to plug in values. So if we rearrange this one, we can say D square, this will be equal to K divided by I. K divided by I, so we need to find out value of D, so this will be equal to K divided by I, the root of this one. So value of K we have, that is 15.7, and value of I we have, that is 4, or simply you can say 8 minus 4, and if we solve this one we will get the final answer. So this is up to 3SF 1.98, but as in this case the least number of SF we have is 1 and the maximum is 3, so it's better to write down up to 2 SF. So we can say this is 2.0 meters. So this is our final answer. So this is how you can answer. I hope this paper was helpful, means this video was helpful. Please like and subscribe, and if you have any questions you can leave in the comments, and if you're looking for extra resources you can join Patreon, and also paper and mark scheme you can also find on Patreon. That's all for this video. See you in next video.